Good evening, everyone. My name is Sampath. I'm here on behalf of the Electronics Club. So we here present to you the first big event that we have, which we call the piano stairs. Okay. We have a reason to believe that stairs can be made more interesting, more fun by making stairs a piano. Well, you must be feeling I'm out of my mind, right? No. So what we here want to do is like we want to make a set of stairs, give out certain kinds of sounds when you step on them. Okay? And we believe that this is a great way to introduce the freshmen here to electronics. So we just don't want to continue the same trend of workshops every year. So this is, we feel, something new. Okay? So what we have as our basic system is sensors that detect the step on a particular stair, a microcontroller circuit which you can call a black box that will check which step has been stepped on, and a speaker which produces the sound corresponding to a certain step. Okay? So that is what we have. We'll be showing you the demonstration, and also we'll be having certain doubt clarification sessions with the freshmen to see what kind of doubts they have and say how they can be addressed. Thank you. You were saying something?
Digital is 0-1 signals, right?
Yeah, digital is 0-1. So in theory it is 0-1, but when it comes to practical implementation of that 0-1, a 0 is basically a very low voltage. It can be anything, but usually it's a low voltage, which is usually the ground of the entire circuit. And your 1 is essentially usually the highest voltage in the circuit. So the reason why 0 and 1 is used because there is a huge difference between both. And even if you have some noise in the circuit, you can't confuse a 0 for a 1. But you can actually confuse a 1.1 for a 1.2 because of the noise. But you can't confuse a 0 volts with a 5 volts. So essentially a voltage of 5 can be considered to be an analog voltage. It's continuous. The range, the voltages that analog signals can take are infinite. The range is unbounded.
So this is the piezo sensor, only the number depends on the pressure that you apply. So this is because of the digital converter, irrespective of the pressure you apply, the sound will be different.
No, you can actually change the intensity of the sound also.
That depends on the coding which you do in the...
Because in the microcontroller, it need not give only a digital signal that is 0 or 1. It can give a digital signal that varies in steps.
Okay.
So 0-1 is 2, 1-1 is 3, sorry, 1-1 is 3, yeah. So that is basically how it goes.
You can make it different.
So, do you know what a piezo sensor is made up of?
Piezoelectric material.
Yeah, what is a piezoelectric material?
Which generates voltage and pressure.
Yeah, so it's basically, there is a special kind of material that can measure stress along its surface. And due to alignment of some certain magnetic domains, there is a voltage output that comes across the different layers. So essentially a piezoelectric material, a sensor, is made up of many layers of piezoelectric crystals. Because each layer of crystal can only produce so much voltage, so you attach all of them in series. And then you get the piezoelectric sensor.
Hi friends, I am Surya Pratap Babar, the coordinator of Electronics Club IIT Bombay. Today we are here to make piano stairs, a tech for fun event. This event was basically for freshers. In this event, we tried to introduce sensors to the freshmen. The sensors that we use were piezoelectric sensors. So now what are piezoelectric sensors? Piezoelectric sensors are sensors which generate a potential difference across the two terminals when some pressure is applied between them. So here what we are doing is, we have put a piezo sensor under an aluminium strip. The cotton provides a cushion to the piezoelectric sensor so that it's not overpressed and oversaturated. A main problem with piezo sensor is saturation of charge. The charge needs a path of current to discharge the piezoelectric sensor. So what we have done here is applied a 1 mega ohm resistor between the two terminals of the piezoelectric sensor. the golden part which you can see is a metal plate and the white part is the same, a metal plate. The piezoelectric material is between them. So what happens is that when we step on the step, potential difference is created of some millivolt. Now this potential difference needs to be scaled up. Now why do we need to scale up this potential difference? All the electrical components that we have used in this project work preferably between 0 to 5 volt, which is divided in 1024 parts. So it is around 3 millivolt for each part. Now when we get an output through the piezo sensor, it gives me a 5 millivolt to 10 millivolt output. Now to differentiate between these two, we cannot use just 2 units of our processor. Hence we have used a AVR Atmega 32 processor to scale up the intaken analog input. So as you can see, as I apply some pressure on this aluminum strip, the piezo sensor gets pressed, a potential difference is generated, which is analyzed by the microcontroller Atmega 32 that we have used. That analyzes it, tries to make some harmonic and passes on the digital step up and step down signal to the piezo buzzer that we have used. So right now we have been successful in making 2 stairs, as you can see, and this one. We will be continuing the same with the rest, right? AVR Atmega 32 board. This is a microcontroller board, a development board. The microcontroller which you see here is an Atmega 32 microcontroller. These are the input output and the analog and digital input output ports. What we have done in this project is that we have taken the inputs from port A. The analog inputs have been taken from port A. They have been analyzed by the microcontroller, and a buzz is being produced through the port B according to the input analog signals. The piezo sensor is basically of this type. We have a metallic plate. As you can see, the golden color is a metallic plate. This white color plate is also a metallic plate. This is nothing but the 2 terminals of the piezo sensor. The major piezoelectric material is between these 2 plates. As you can see, what happens is that when I press or apply some pressure between these 2 ends, a potential difference is created by the piezoelectric material. This being the property of the piezoelectric material, that we have taken these inputs into the AVR board and analyzed them. We are taking the outputs through the piezo buzzer. Later what will happen is that we will be taking the output through the we will be taking some digital output, characterizing it through an IC, and then forwarding the major 12 volt source to the amplifier.